Now we're going to have a presentation on Charles's law, still part of section 14.1. My recommendation is to print out the notes from my PowerPoint and have them ready to go. Going to be a sample problem there. Plus also you'll find on my website that there's a video, an applet, and also a video on my PowerPoint slides. So as you're printing those out, you'll definitely want to watch those. Do the applet, it's an online applet that you can do, and then the video showing you what happens when volume and temperature changes. Let's take a look at Charles's law. It is the volume of a fixed amount of gas. That's the volume is directly proportional to its Kelvin temperature if the pressure is kept constant. So this law deals with volume and temperature. Our other two variables when we talk about our gas laws, the pressure and the amount of gas are held constant in this case. Temperature is very, very important. Temperature needs to be in Kelvin. I cannot stress this enough. That temperature in Kelvin is a must. We cannot have any negative numbers associated with our gas laws. So it must be in Kelvin because the Kelvin scale starts at 0 and goes up from there. So temperature is in Kelvin. The equation that we use is V1 T2 is equal to V2 T1. So the initial volume times the final temperature is equal to the final volume times the initial temperature. Again, we can use V's and V primes if we want. V times T prime is equal to V prime times T. Either way, doesn't matter. We can use letters, we could use numbers, anything as long as we know there's a difference between the initial and the final. So as I mentioned before, if you go to my PowerPoint and click through the slides, you'll come across this screen and you will see up here there's the word applet. Click on that applet and you will go to a computer website where you can adjust. You can change the temperature. You want to slide the temperature bar back and forth, and you can see what happens with the volume. It'll graph it out for you, and you can see what's going on there. There's also a video on the next slide. So this video that you'll see on the next slide is a good illustration of what happens when you change the temperature. And I'm going to just skip that here because we can't show it on this part of it. Let's do an example of Charles's law. Here's what would be a standard question. What volume will a sample of nitrogen occupy at 28 degrees Celsius if the gas occupies a volume of 457 milliliters at a temperature of 5 degrees C? Pressure is held constant. So the first thing that we want to do, as always, with any of these problems, is to write down our knowns and unknowns. Very important to do that. We're getting into more gas laws now, and we're going to have to differentiate between them. And the way that we do that is by actually writing out the formulas, or write out the formulas and by writing out the knowns and unknowns. So the first thing we're gonna want to do is check out what's our initial volume, what's our final volume, and our and our temperatures, initial temperatures and final temperatures. So what we have here, the whole key is to keep them together. Whatever we have for our volume, we need that temperature to match up with it. So this one says, what is the volume of a sample, or what will the volume of a sample occupy at 28 degrees C? So we're just going to arbitrarily set the V2 is equal to question mark. We know that this what volume is going to be at 28 degrees. So that's going to be our T2 because our unknown volume will be at that 28 degrees C. So that leaves us volume 1 at 457 milliliters and our temperature 1 at 5 degrees Celsius. So the first thing we have to do is that we note that we are in Celsius. We need to convert all these into Kelvin. The way to do that is to add 273, and that will give us our Kelvin temperature. So for this first one here, that will be 278 K. For the second one, we add 273, and we will end up with 301 K. So again, everything needs to be in Kelvin before we do anything. Then the next thing we want to do is write down our formula. We will have V1 T2 is equal to V2 T1. There's our formula. Now we have our knowns and unknowns sitting here. Now we just plug and chug. V1, our V1 is 457 milliliters. We write it down. Times, that's going to be our T2. Our T2 is 301 K. That's going to equal our V2. V2 is a question mark, so we'll just write V2 there. Times our T1. T1 turns out to be 278 K. So we put that down there. Now we need to solve for V2. Solving for V2, everything needs to go on the other side, so we'll just divide both sides by 278K. 278K. That'll cancel, and we'll end up with V2 equaling our 457 times 301 divided by 278K, and we will end up with 495, and our units will be milliliters because our K's will cancel here and we'll be left with milliliters as our units. Again, the whole key with any of these problems, deciding what your known and unknowns are. Decide, see what you have, see what variables you have, and make sure they're matched up. V1 is matched up with T1. V2 is matched up with T2. Make sure those numbers correspond with each other. As soon as you have the knowns and unknowns, you can decide what formula to use. We learned about Boyle's law with pressure and volume changing. This one is constant pressure, so we know we're not going to use that formula. We use the formula that just contains volume and temperature. That's going to be our Charles's law. So key things to remember, again, I can't stress this enough. Write down your knowns and unknowns. Write down your formula, and then plug and chug. Hopefully you got a lot out of this lab or this presentation. We'll see you later.